Hello again, another example with forces acting on objects with an inclined plane. I have a rope that passes over a frictionless, massless pulley as shown in the figure, below attached to two masses to each other. Find the direction and the magnitude of the acceleration of mass m2 on the right side, 2 kg, if m1 was 3 kg on the left, where the angles for m1 theta 25 degrees and phi 45 degrees on the inclined side under the m2. Okay, now in this case, to determine um, which side the acceleration will be, or which side the system will be moving, it's not just by looking to the masses. We're saying, okay, M1 is 3 kg, it will be winning. No, you need to remember this is not on a flat surface where I am pushing or dragging something. This is an incline plane. There is a component of the weight is the one gonna be causing the motion. It's the X component, or the parallel of the inclined surface component of the weight, the one will be deciding which direction the motion will be happening unless there is an external force acting. So as a start, I will distribute the forces, or I'll do the free body diagram for M1. Here we go. It's M1G, and as mentioned before, that will be M1G cosine theta. Here I will have M1G sine theta. Also, I will have the normal force, and this is the tension. Okay? Now, if I'm gonna go to the second one, or the mass 2, same scenario. I will have M2G, where I have here, it's M2G cosine phi. Here will be M2G sine phi, and I'll have the normal force, which I could call it Fn2 because it's coming or related to object 2, and here we can call it 1, I'll fix that, and T. So here we go, we can call it Fn1 in case if we needed to distinguish between them, because they will do have different values. Now, to decide which direction will be the motion, I have to know how much is, or calculate the m1g sine theta. So it's gonna be 3 9.8 multiplied by sine 25 degrees. If I go to my calculator, that will give me 12.4. So 12.4 Newton, that's the X component of mass 1. Let's go to M2G sine phi. So again, here we have 2 multiplied by 9.8 multiplied by sine 45 degrees. That will give me 13.8 and Newton. So from these calculation, I can see that the component, or the X component, or the the parallel component of mass 2 of the weight is the one gonna be heavier, or the bigger, so it will be accelerating, or the system will be moving to this way. That's gonna be the positive acceleration. Now, to determine how much is this acceleration, we're gonna put this a bit aside for a bit, and let's go like from other examples. For M1, we're gonna apply Newton's law, where is the total forces equal A. Now, what are the forces on object 1? Going with the same direction, it will be T minus m1g sine theta, and that will equal m1a. All right? For m2, I will have m2g sine phi minus t equal m2a. Once again, I have an equation system. The tensions will be eliminated. Then we will calculate whatever left here. I will have m2g sine phi minus m1g sine theta. And here we go. I can take the acceleration as a common factor, and m1 plus m2. Here we can calculate the acceleration. Well, it's m2 g sine phi, which is something you can do to take the g as a common factor between these two things or these two terms, but we know we did calculate them before to determine the acceleration direction. So I know how much is the m2. It's 13.8 minus 12.4 on, you divide it on 5, and that will give you the value of your acceleration. So let's do that. 13. That will give us 0.28. Sorry, I'll fix this one quickly. That will give us here 0.28 meter per second square, and that will be the acceleration this system of two masses will be moving to the direction we determined at the start of the question. All right? I hope you found this example useful, and I'll see you again with another one. Thank you.